Hello, everyone. So we're going to get back into our next unit, which is going to be about equations specifically. And in our first section is going to be translate to equations. So we're going to be translating sentences and word problems, I guess you could say, into an equation. Now, some of you guys might be really strong with this already, and you might think that this video is not needed for you, but I can't tell you how important it is for you to be able to translate words into an equation. Math is a language, and one of the problems I see that people struggle with the most is whenever you get word problems, they struggle with turning that word problem into a mathematical equation. They struggle with the translation from, in our case, English, to a mathematical equation. Right? So it's very important. So even if you think that you are super strong on this, it's something you still have to take serious. And if you struggle with this, this is where we can build on it. This is where we can get better. So our learning objective in this video, it's just one thing, that you'll be able to translate a sentence into an equation. That's all that you need to be able to do by the end of this video. All right, hopefully this video is not very long. The majority of this is going to be going over definitions and key terms, and then it's only going to be very short of going over actual examples. All right, so what I would suggest that you do now is that you pause this video, because this is a lot of writing for you to copy down. You must have all of this copied down if I check your notes. All right, so I would suggest you pause this video and write it all out. And then after you write it all out, then you can press play, and this way you can fully focus on what I'm saying. All right, so these are all very important key terms that you must know. A variable is a letter or a symbol used to represent a value that can change. It also represents an unknown value. So we've already dealt with variables this year, so this isn't new for you. So you should all be very comfortable with what a variable is. And remember, I told you that you guys can use anything you want. And the reason is because you have to define your variables. And that's something that we're going to start learning now, that you must define your variables. All right. So in this case, an x, y, z, those are some of the most common variables that you'll see. T as well. But you can use anything you want. But as long as we're defining our variables, which we're not going to learn in this video, but we'll learn later on in this unit. As long as you're defining them, it's perfectly fine. Right? A constant is a value that does not change. That's going to be all of our numerical values that aren't being multiplied to a variable, that are just being added or subtracted to within our expression or within our equation. So, for instance, 4 is a constant. -8 is a constant. Pi is even a constant. And in this case, 512. All right, so those are all constants. Now, once they get multiplied to a variable, then we change their name. So we don't call them a constant anymore at that point. So it's a value that does not change. So it's a numerical value that is just being added or subtracted to our problems. All right, a coefficient. Now, whenever we do have a number or a constant quantity that is being multiplied to a variable in an algebraic expression or equation, we no longer call that a constant, we call that a coefficient. So in this case, if I were to take this 4 and say, instead of writing it as 4, I wrote it as 4 times x, well, this 4 is now our coefficient. If I wrote it as -8 times y, well, this -8 is now our coefficient. If I wrote it as pi times t, well, pi will be our coefficient. And 512 times z, 512 will be our coefficient. So once we take those numbers and we start multiplying them to a variable, they no longer are called constants, but they're called coefficients. All right, and then the last one, an equation, is a mathematical sentence that uses an equal sign to show that two expressions are equal. Now, you need to know how to identify an equation based on words. And the most common one that you'll see is they'll say 5 is x. Well, this is, in this case, is telling me 5 is equal to x. Right? Is a way that we can say equals. Or that have the equal sign. You might also see it as the same amount or something along those lines, but is the most common one, and whenever you see that, it's going to be your equal sign. All right, and then just real quick, we have these two, an expression and an equation. Well, the difference between them is an equation is taking two separate expressions or two or more expressions and setting them equal to each other. So in this case here, this 4 plus 8 is an expression, and so is this 12. And you see now we're setting them equal. In this case, we just have 4 plus 8. When there's no equal sign, it's considered an expression. All right, once again, x plus 8, there's no equal, that's an expression. Well, now if I take that expression of x plus 8 and I set it equal to another expression, it becomes an equation. All right, so the main thing you have to realize is that when I say write an expression, there's not going to be an equal sign. If I say write an equation, you better have an equal sign. All right, and some of you on your last assessment, you guys weren't including your equal signs there. All right, there's just a few more terms that we have to go through before we get through some examples. All right, so I'm just going to go through plus and times very quickly because there's really nothing that can really trip you up with that. But if you see the word plus or sum or increase by, like, you should know that this is going to be an addition. So first thing you'll see me do is when I go through these sentences, I try to identify what are my operations. And then from there, I start filling it in. So just all of these, if I say, they just go in the order. So if I say 7 plus 5, then I would write that as 7 plus 5. If I say the sum of 7 and 5, well, then it's 7 plus 5. If I say increase by 7 increased by 5, that's still 7 plus 5. So for addition, there's really no trip ups. There's no way really to be confused. You just go in that exact same order. All right, the next one, times for multiplication, we can see it as times product equal groups of. And the same thing, it really doesn't matter. It just goes in the order. There's no way for you to get tripped up with any way that they write that. Just goes in that order. And so for times, if I said 7 times 5, that would be 7 times 5. If I said the product of 7 and 5, well, that would be 7 times 5. And 7 equal groups of 5 will be 7 times 5. All right, so now I'm going to get in these two, which I think are a little bit trickier. The divided by one should be fairly simple. You should know that that's division. Just quotient. I just want to go through that one because if you were to mistakenly write 5 times 7, you would still get the answer right if you're trying to solve. But if you mix up your quotients, you're not going to get it right. So I'm going to give you an example real quick of how we will see quotient and how you should write it. All right, so here we have the quotient of 8 and 2. All right, so since 2 divided by 8 does not equal 8 divided by 2, we need to make sure we're writing this correctly, especially if we're going to try and solve a problem with this later on. So the order that you write it is the order that our numerator and denominator goes. So the first number that we have is going to be our numerator. And then the second number that we have is going to be our denominator. So the quotient of 8 and 2 is 8 divided by 2, or 8 over 2, however you would like to write that. All right, so for quotient, the order matters in the way that it goes. All right, so now we're going to get into subtraction. So here, here we have minus. So same thing, like for the most part, these are pretty easy. I'm going to go through these two. I'm going to write examples of difference and less than, and then show you real quickly before we get to our examples. All right, so for this here, I'm going to change my ink color. Let's just do purple. All right, so for this here, the difference of 8 and 2, it's exactly like our quotient because once again, I want to go through this because 8 minus 2 does not equal 2 minus 8. They are not the same thing. So if you're trying to solve a question, you need to know the order that you're writing it. And whenever you see the difference of, we're going in the order. So that means that we will be subtracting 2 from 8. So this would be written as 8 minus 2. So whenever we see the difference of, the first number is the number that we're subtracting from, and the second number is the number that we're subtracting by. All right, so just make sure that you know whenever you see the difference of, it goes in that same order. Now, this is the one that a lot of people seem to get mixed up on and really struggle with. Whenever you see 7 less than 16, what they think is, oh, well, then we're going to do 7 minus 16, but that is not correct. Think about what we're saying. We're saying 7 less than 6. Well, what number would be less than, less than 16? What number is 7 less, like which number would be 16 minus 7? Which number would be 7 units less than 16? So whenever you see this less than, the second number is actually the number that we're subtracting into. And then the first number is actually the number that we're subtracting by. So this will be 16 minus 7. All right, so that's the one that a lot of people seem to get tripped up on. All right, so make sure that you're paying attention to the order in which we're writing that. Of 7 less than 16, so think about it. We're going 7 units less than 16. That means that we're going to be 7 units to the left of 16, or 16 minus 7. All right, so now we're going to get into some examples. It shouldn't take too long at this point, and then after you do some examples, you're going to do some on your own that you'll submit. All right, so let's just go through these quickly. And what I'm going to do is, as I go through and read these, I'm going to rewrite them. I'm going to highlight the important word, and I'm going to rewrite the operation or what it means mathematically. So number y decreased by 4. Whoa, once I see this decrease by, I should know that that is telling me subtraction. So I'm going to go ahead and write subtraction above. And then number y decreased by 4 is 3. So once again, I know that is means equals. So now I can rewrite this. So y decreased by 4 or y minus 4. I'm going to write y minus 4. And then here I know is equal. And it's just saying it's just equal to 3. So it's just going to be y minus 4 is equal to 3. Right? From here, 48 equals. Well, this one, they made it really easy for me because it's just flat out says the word equals. So I know it's going to be equals. 12 times a number. Once again, I made this one really easy for me as well because times a number, there's no way I should be able to get that mixed up that that's not multiplication. And now I'm going to go ahead and write this out. So equals, and it's just going to be equal to just this number 48, right? It's not always going to be equal to just a number. Sometimes we'll have variables on both sides of those equations. So it's important to identify what's on one side of the equation. So in this case, 48, see how I'm underlining it, and what's on the other side. All right, and then from here, it says 12 times a number p. Well, 12 times a number p, we can just write it as 12p. If you wrote it as 12 times p or 12, I just don't want you to use this x because how do I know that's not a variable x? Right, so from this point forward, if you're going to write multiplication and you're not going to just write the numbers next to each other, then you just got to write this dot, or you can go ahead and write an asterisk. All right, but don't write an x because now we're going to be dealing with variables. All right, let's move on to the next one. It says the quotient of a number. Well, once again, I know quotient is going to be division. So I'm going to write that above it. Of a number q and 4. So remember, it goes in the order. So I'm going to write n and d here just because that means I'm paying attention to what my numerator and denominator is. And then it says is, so I know that this is going to be equals. So is 12 can be rewritten as equals to 12. And now remember, the first number is going to be my numerator, so I know I can write q in my numerator and over top of 4. So I could write q divided by 4. I could write it like this as well if I would like to. Either one will be acceptable, but it's up to you with how you want to write that. When you are typing into your computer, because you will need to, I would highly suggest that for division, you were going to use your backslash. All right, so now from here, let's go ahead. Our last one, a number k increased by 10. Well, what does increase by? If I take a number and I'm increasing it, well, that means I'm adding to it. So I know that that's going to be adding. And then it says, is the same as. Well, is the same as is another way for us saying equals. So let's go ahead. I know my equal sign's here, so it's just equal to 24, so that's easy for me to write. And then it says k increased by 10. So we knew increased by was plus, so it would be k plus 10. For now, if I'm checking on how you write them, I don't want you to write 10 plus k. Even though that they are equal to each other, this is not how I want to see it written because it's not the order in which it's written on your question. So please make sure that you are following the order for multiplication and addition when you're doing this as well. Really, though, for multiplication, if you ever have a coefficient, that always gets written out front. So you would never write P12 anyway. It would always be 12P. All right, that is it for this video. And there's going to be some questions you have to do.